Hi everyone, welcome to Siva Science Galaxy. In this video, we are going to discuss about basicity of amines. So what are amines? Amines are organic compounds and the amines are derivative of ammonia, NH3, and the nitrogen has a lone pair of electron. By replacing the protons, one protons or more than one protons by alkyl groups or aryl groups, amines can be derived. So there are two main classes of amines, alkyl amines and aryl amines. First we will discuss about alkyl amines. In alkyl amines, one proton or more than one proton will be replaced by R groups. So the amines are R, NH2, R1, R2, NH, R1, R2, R3, N. The first one can be called as primary amine. The second one, this one is called secondary amine. And this is tertiary amine. In the cases of secondary amine and tertiary amine, if R groups are identical to one another, then the amines can be called as simple amines. If R groups are different from one another, those amines can be called as mixed amines. Now let us talk about the aryl amines. In the aryl amines, the protons of ammonia, one or more than one protons of ammonia will be replaced by aryl groups. For example, consider this one. So in this case, one proton of ammonia is replaced by a aryl group. This is called aniline. Okay. So these are alkyl amines. This is aryl amines. Now let us discuss about basicity of amines. The basicity tells about the ability of amines to form their cation salts upon reacting with acids. Now let us consider the reaction. RNH2, the presence of water, it becomes RNH3 plus and OH minus. This is cation salt of this amine. Cation salt of this amine. The basicity strength of amines is generally expressed by pKb. pKb. pKb is equal to minus logarithm of Kb. Kb is dissociation constant of amine. Dissociation constant. Dissociation constant of amine can be called as Kb. From the Kb we can calculate the pKb. The Kb can be calculated on the basis of this expression. Kb is equal to concentration of R, NH3 plus and OH minus divided by R, NH2. So from the Kb we can calculate the pKb. From the pKb we can calculate the Kb. Kb is equal to 10 to the power of minus pKb. Now vice versa we can calculate. Now what is the importance of the pKb? If pKb is smaller, stronger the base. If the pKb is larger, weaker the base. So on the basis of the pKb value we can understand whether the amine is weaker or stronger. Now let us discuss about factors affecting the basicity strength of amines. The strength of amines depending upon the cations formed from the amines in the reaction. The cation should be stabilized and should be soluble in water. In other words, depending upon the stability of the ions, and the solvation of the ions, the strength of the bases will be affected. Now let us discuss about the stability of the cations. Cations formed from the corresponding amines. The stability of the cations depending upon the groups substituted in the amines, which can be R or AR, alkyl groups or aryl groups. If the substituted groups can be either electron donating groups or electron withdrawing groups. The substituted groups can be broadly classified into electron donating groups and electron withdrawing groups. If the substituted groups are electron donating groups, the cations will be stabilized. Consequently, the strength of the amines will be increased. If the substituted groups are electron withdrawing groups, the cation stability will be reduced. Consequently, the strength of the amines will be decreased. So, depending upon the nature of the groups, the cation may be stabilized or destabilized. Accordingly, the strength of the amines will be affected. So, now let us talk about the solvation effect. Solvation effect tells about the extent of the solubility of the cation in water. The higher the solubility, the higher the strength of the amines. So the solubility of the cations depending upon the groups. Once again, the groups in the amines. If the groups are smaller, the solubility will be high. If the groups are bulky in nature, the solubility will be decreased. So higher the solubility, higher the strength of the bases. So depending upon the size of the groups, the strength of the amines will be affected. In addition to that, if the groups are so bulky, it may prevent the hydrogen bond formations. That effect can be called as steric hindrance. Steric hindrance. Steric hindrance is because of the size of the groups in the amines. If the groups are so bulky, it will not allow the molecules to form hydrogen bond with the water molecules. So because of these reasons, the solubility will be affected. In other words, solubility will be decreased. Because of decrease in the solubility, the basicity strength of the amines also will be decreased. So what is the point over here? The basicity strength of the amines are increased when the cation's stability is increased and the cations are highly soluble in water. When the solubility is high, stability is high, the strength is also high. When the stability is less, solubility is less, the basicity strength of the amines also will be lower. Now let us discuss this concept with a few examples. Now consider these amines: CH3, NH2, CH3, CH3, NH, and CH3, CH3, N. So we have methylamine, dimethylamine, and trimethylamine. So methyl groups are electron donating groups. Methyl groups are electron donating groups. So electron donating groups will stabilize the cations formed from the corresponding amines. So more the electron donating group, more the stability of the cations. So according to the concept, the stability concept, we can say tertiary amine should be stronger than the secondary amine. Secondary amine should be stronger than the primary amine. This is the order we expect on the basis of the stability of the cations that may be obtained from these corresponding amines. Now, we also should consider about the solubility of these amines in water. In the sense, the cations formed from the amines, the solubility of the cations formed from the amines in water. Now, that solubility depending upon the nature of the groups in the amines. Smaller the groups, higher the solubility. So, according to that concept, the primary amine CH3, NH2 will be stronger than this amine, secondary amine, dimethylamine, CH3NH. And this should be stronger than tertiary amine, trimethylamine, CH3NCH3. So on the basis of the stability, this is the order we expect. On the basis of the solubility, this is the order we expect. So these two effects should be compensated. So by tie together of this effect, the basicity strength of the amines will be governed. So in the cases of these three molecules, the actual basicity order is the strongest base dimethylamine, CH3NH is stronger than the methylamine, CH3NH2, and this is stronger than trimethylamine. So this is because of solubility as well as stability effect. So in this case, in the case of tertiary amine, so the three methyl groups are electron donating groups. However, because of the bulky nature, because of the bigger nature of the molecules, the solubility is affected very drastically. So the solubility effect also should be taken into considerations. Accounting the solubility effect, this amine is weaker of these three amines. Now let us consider another example. C2H5NH2. C2H5 twice NH. C2H5 thrice NH. So this is ethylamine, this is diethylamine, this is triethylamine. What is the order? The order is the diethylamine is stronger than trimethylamine. So C2H5 twice NH is stronger than C2H5 thrice N. So this is N, tertiary N. Now this is stronger than C2H5NH2. So the prediction of the basicity strength of amines is not so straightforward, because there are two effects: the stability of the cations as well as the solubility of the cations in water. Since the basicity strength of the amines is a complex process. So as you can see, in this case, diethylamine is stronger than triethylamine. But in the case of methylamine, diethylamine is stronger than methylamine. Methylamine is stronger than the trimethylamine. Suppose I give another example. You consider, you compare the ethylamine and methylamine, CH3NH2. So which is stronger of these two amines? This is probably straightforward example. One can say ethylamine is stronger than methylamine, because ethyl group is electron donating group. Methyl also electron donating group, but ethyl is much stronger than methyl. So we can say ethylamine is stronger than methylamine. But when we have more than one alkyl groups in the amine, the basicity strength of the amine is going to be much more complex. Now let us consider another interesting example. This is Aryl amine. This is aniline. The cations of anilines going to be like this. NH3 plus, and here we have lone pair electron. So now whether the aniline is a strong base or not. So in this case, what we have to do is we have to see the resonance structures of the aniline as well as the resonance structure of the salt formed from the aniline. The structure which has more resonance structures is the highly stable structure. If aniline is stable, it's going to be a weak base. If the salt formed from the aniline is more stable, then the aniline going to be a strong base. Now let us see the resonance structures of aniline as well as anilinium ion. This is called anilinium ion. aniline ion. So on the basis of the number of the resonance structures for aniline and anilinium, we are going to say whether the aniline is strong base or not. Let us draw the structure for aniline. So now this structure is in resonance with this structure. Actually, I should write these two structures are resonance structures. Now the lone pair of electron may be shifted over here, so that this will be shifted here. Now this can be in resonance with this structure. This is going to be minus, and this is going to be double bond NH2, and this is going to be plus. Now this structure will be in resonance with the structure I am going to draw over here. So what happens is this moves here and this moves on here. Now this structure will be resonance with the structure I am going to draw over here. So the aniline has 5 resonance structure: 1, 2, 3, 4 and 5. So there are 5 resonance structures exist for the aniline. Let's see how many structures for the anilinium ion. This is anilinium ion, structure 1. This structure is in equilibrium, is in resonance with this structure. With this structure only. So anilinium ion has only 2 resonance structure, whereas aniline has 5 resonance structure. So since aniline has 5 resonance structure, aniline is much more stable than the cations of this amine, that is anilinium ion. So aniline is more stable than anilinium ion. So aniline is weak base. Okay, let me explain one more example. Now consider the 3 molecules. And this is aniline, NH2. Now consider another molecule. Now consider another molecules. So now we can compare the basicity strength of these 3 molecules. Now what we have here proton. So here we have proton, in this case we have methyl group, in this case we have the NO2 group. Methyl group is the electron donating group. NO2 is electron withdrawing group. So H is a neutral. So the electron, since we have electron donating group in this molecule, this is going to be stronger than this, and this is going to be stronger than this. So in other words, this is stronger base, this is weaker base among these 3 molecules. So the order going to be, this is stronger 1, this is 2, and this is 3. I hope you all understood the concepts of amines and basicity of amines. Thank you so much for watching the video.